These examples come out of the review preview section for Chapter 4. So the first thing we're asked here to express as an inequality something that's given in interval notation. This is something hopefully you've run into before in Math 30 or even in just the welcome assignment to Math 31. But this notation here just means that the negative 3 is included and x needs to be anything larger than negative 3. So x is greater or equal to negative 3. You don't need to say that it goes up to infinity. Infinity is not a number, so you're just saying anything bigger than negative 3 and including negative 3 is what the square bracket means. Round brackets, on the other hand, mean that that number is not included. And so in the second question here, I've got 7 is less than equal to x, which is less than 10. Round brackets, no equal sign. Square brackets, you get the equal sign. So to go the other way, if I've got inequalities and I want to express an interval notation, I've got a round bracket for the 2 and a square bracket for the 3, and that would include all numbers between 2 and 3, including 3, not including 2. So this next one is actually solving an inequality. I've got something, thankfully, that's already factored. X plus 1 times 2x plus 1 times x minus 6 is greater than 0. When you had a graphing calculator to do this, you could just graph that and see where is it above the x-axis. But here, what we're looking to do is figure out when this is going to be positive. I like to use a number line and put just the important values here. Negative 1, negative a half, and positive 6 are the only places where this would equal 0. And since we don't want it to equal 0, those aren't part of my solution. The only question now is, to the left and right of each of those values, does this thing equal, or is it greater or less than 0? So if I pick a number to the left of negative 1, like negative 100 or negative 2 or negative a billion, I'm going to have a negative times a negative times a negative, which means it to be less than 0. So those numbers are not part of the solution to satisfy the condition greater than 0. If I pick a number in between negative 1 and negative a half, now that's a little bit trickier maybe, but it's, pick negative 0.6 or something like that, you will have a positive times a negative times a negative, and you will have positive answers in there, which means that answers between there are part of your solution. So you want to say that x between negative 1 and negative a half is part of your solution. Now I try numbers in between negative a half and 6, try 0, and I've got positive, positive, negative, which makes that negative, and those would not be part of the solution. Finally, numbers greater than 6, and you can pick 7, or you can pick 700 billion if you like, and you have positive, 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 and those numbers are also part of the solution, so x can also be greater than 6. So in inequality notation like that, you could also write those in an interval notation if you liked, to say negative 1 comma negative a half, and 6 comma infinity, all round brackets, because none of the end values there are included. This next one quite similar, another inequality, a couple of differences. First of all, it's a quotient, so there's x plus 2 divided by x minus 3. It needs to be less than or equal to 0. I still look at this in a very similar way. If there's factoring to do, I'd factor it, but it's already as simple as it can get. The only two important numbers here are going to be negative 2, but also positive 3. Anywhere where this thing is equal to 0, or anywhere where it's undefined, in this case, could be answers to this set here. Now, if I put in negative 2, it equals 0, and that means that is actually part of the solution. Negative 2 would satisfy the condition less than or equal to 0, because it would make it equal to 0. 3, however, wouldn't, because that's undefined and does not satisfy. Now the only question is, what about the intervals to the left, to the right, in between? Try a number to the left of negative 2, negative 200 if you like, and you have a negative over negative, which is a positive, does not satisfy less than or equal to 0, so those numbers aren't part of the solution. Pick a number in between. 0 would be an easy one, and you've got 2 over negative 3, so we have a positive over a negative, which is negative, which means that the numbers in between there are part of my solution. So everything from negative 2 up to 3 is going to be part of the solution set to this question. And if I try a number larger than that, I'm going to have positive over a positive, which is positive, and I don't have a solution. So all the answers are going to be in here. In interval notation, that's going to be -2, 3, square brackets, round brackets. You wouldn't have to put both of those, just put one or the other, whichever one is making the most sense. Interval notation starts to get a little faster when you have multiple intervals.